Okay, so now for problem 11 out of the textbook, and this is 4.1, right?
Yes.
Okay. Problem number 11 says that we have f of x is equal to 1 over x plus the natural log of x, okay? And it's given us a closed interval of 0.5 to 4. And so this is another way to write 0.5 comma 4. Right? So that's our relative domain. So we already have 2 of our critical points, right? So they want us to find the extreme value of this. But clearly we could go in our calculator and just calculate what the min and max are, right? But what we want to do is we want to follow the process. So we want to find the critical points. Well, those are 2 of them. And so so that's step 1. Consider the boundaries. 2 would be figure out when f prime of x is equal to 0. So now we got to find f prime. So we're going to say f prime of this. Now remember that 1 over x is the same as x to the negative 1, right? I think of it that way because the power rule is so much easier to do here. So that means I'm going to toss the negative 1 to the front, right? And then that becomes x to the negative 2, which is the same as negative 1 over x squared, right? Okay, so I'll write it down. This negative 1 gets tossed to the front.
Yeah.
That's how I get the negative 1. And then we subtract 1 from negative 1. So what's negative 1 minus 1?
Negative 2.
What's x to the negative 2?
That's it. Okay.
Does that make sense?
Yeah.
Okay. Now who can tell me what the derivative of the natural log of x is? That's one of those
1 over x.
1 over x. You just gotta memorize that, right?
Mm-hmm.
I mean, you could calculate it by hand, but if you memorize it, it's pretty good. It should be 1 over something times the derivative of something. So it's technically 1 over x times the derivative of x, which is just 1. All right? So that's positive 1 over x. Well, that will equal 0 in some cases. So let's plug that in. So how would you... I've got negative 1 over x squared plus 1 over x equals 0. Now, somehow algebraically we want to solve that. There's lots of ways you can do that. What do you guys recommend? Well, I'll let you in on a clue. The numerator is 1 and 1, or negative 1 and 1, right? So if I can make, what we're really looking for is x squared and x to have the same value.
You square the 1 over x to make it 1.
Do you what?
Take out a 1x. Take out 1 over x. But yeah, like
Hey, I'm willing to try. I was going to think of one way to do it, but let's try this. What do you mean, like have a common denominator? Is that what you mean? Yeah, all right. We can try that. So if I hit this with an x on the top and the bottom, it's a little bit more work for us, but that's okay. It'll give us the answer. What we end up with is 0 is equal to negative 1 plus x, right, all over x squared. Is that right?
Yeah.
Okay, now algebraically, if I want to solve this, I suppose, could I multiply both sides by x squared?
Yeah.
Or let me take that back. 1 over, or what, x squared?
Yeah.
Does that make it easier?
Yeah. Yeah.
It does? Let's try it. So if I say x squared times x squared,
Well, because if you times by x squared, then it just stays 0.
X equals
so this is 0 is equal to
and then
x squared
I know it.
times negative 1 plus x. So now we've got to take these and set them equal to 0, right? So I say x squared is equal to 0, and then -1 plus x.
Wait, why?
Wait.
No, you don't x squared
No, there
and go
wouldn't be an x
-1
squared.
plus x because that's the denominator.
Oh yeah, you're right. These cancel, right? Oh good. All right. I thought that's what you guys told me to write
And then
down.
x equals 1.
So these cancel.
Wait, but you suggested this? Like, how to do that? It's like, oh.
All right. So is that right?
X equals
Yes.
1.
All right. So x equals 1, right?
This is the first time I know what's going on all week.
Now, there's one thing I want to point out. Because we multiplied everything by x squared, we want to consider those things. There's another way that we could have done it, but this is right too. What's x? We have to consider the x squared equals 0, sort of, which was still 0, right? So, but I'm going to skip that for now, just for the simple fact. I guess what I'm trying to say is that the equation had an x squared in the bottom. Like 0 and 0 would equal, but they're undefined, right? In other words, we want -1 plus 1 over winky face over winky face, right?
Yeah.
But the winky face can't be 0. So 0 could be a solution to this, right? But it can't because it's undefined. Does that make sense?
Yes.
All right.
Yeah.
So our other critical point is 1. So just to kind of recap, we now have a critical point of 0.5, what was the other one? 4, and 1. Now the only other thing that we need to worry about is when f prime does not exist. And I kind of just said that, right?
At 0.
At 0. F prime will not exist at 0 because we have x's in the denominators here. So x can't equal 0. So then we have 4 critical points. Are you guys with me so far?
Yes.
All right, good. So our 4 critical points are those numbers there, so that means that we need to evaluate f of, and let me see if I can write them in order. I think it's f of 0, f of 0.5, f of 1, and f of 4. And I know that you guys know algebra, and I know that you could calculate this by hand, but I'm going to do the first one, and then we're going to use the calculator for the rest. So our original function was 1 over x plus the natural log of x. So I've got 1 over x plus the natural log of x, or 1 over 0 plus the natural log of 0. Well, that's a crapshoot, right? That doesn't help us at all. We can't do that one. That's the double whammy, right? So this one is no help at all. Kind of like the last problem, doesn't help us at all. So now if I do that for this one, then what I'm going to say is I'm going to say 1 over 0.5 plus the natural log of 0.5. No problems there. We'll use the calculator to find that. 1 over 1 plus the natural log of 1. Uh-oh. And then I have 1 over 4 plus the natural log. Why do I always do that when I write down the natural log? I'll get in a hurry. 1, the natural log of 4. All right, you guys ready? How are we doing so far? All right, so I'm going to slide this over. I know you guys, I'm going to slide this over till I enter it in the calculator, and then I'll slide it back so you guys can see the numbers back. All right, so here we go. Probably the quickest way to do this is just to put it in the graph. So it was 1 divided by x, and then we'll look at the table of values, plus the natural log of x. Table set, we'll start with 0, and we'll increment by, well, we got to increment by 0.5, right? Okay. And so then I'm going to hit second table. And so this stuff here at 0.5, it's 1.3, right? And somebody write this down. And then at 1, it is just 1. At 1.5, or no, at 4, it is 1.63. Okay? So we've got, well, I know what's going to happen. Did you guys write these down yet?
Yeah.
Because as soon as I hit the board, my calculator's gonna go away. So what was it at 0.5? 1 point, was it 3.8 or 3?
3-1.
Okay, we'll just say 1.3. And then at 1 it was 1. And then at 4 it was
1.63.
1.63?
Yes.
Okay. So now, which one's the largest value?
1.63.
So this would be the max. Now, notice Mr. Adams didn't show the graph of this at all. What's the minimum value here?
1.
1. So this should be the min. Now this is, oh, why did I write max? So now this 1.3 business is still important, but it's not extreme. Okay? So now, there might be a hill or valley at 0.5, right? So what we're going to look at is we're going to look at 0.5, comma, 1.3, whatever that is. We're going to look at 1, comma, 1, that's the extreme min, and then we're going to look at 4, comma, 1.63. So I do have that entered in the calculator. Let's verify our results. Hopefully that's right. So let's graph it. It looks a little goofy. So let's zoom in. Standard fit, which is 6. Since we're not going any further than 4 and our values aren't, so I'm going to go like 0 to 4 in the x direction, and then my y direction is all positive, so I'm going to go 0. What was the highest? Like 1.6, right? So I'm going to go 0 to 2. So I'm really going to zoom in there. Now remember, if you look at the graph, right, you can clearly see that right here, when x equals 1 and y equals 1, right, right here is the minimum. So that's the extreme minimum. But then we had x equals 0.5, right? And so if you come up here, that was y equals 1.3. And then if you stretch it, you go 1, 2, 3, and 4 isn't showing on that if I move that. But way over here, somewhere over here is like 4. That would be the 1.6. And so what is the extreme maximum value?
Half and then 2.
Exactly what we calculated, right? And so really what we're considering, and I don't have it all on my computer screen, but really what we're considering is from here to this 1.6 value, which is off the screen a little bit. Does that make sense? Okay.
So you just find the local one by looking at the graph and then looking at what you already calculated.
Well, when the f prime business does, if it's defined, and we find when f prime equals 0, you're going to get a hill or a valley. Okay? Now, if it's not defined, you usually get a cusp or something. Right? Because remember, when you can't get a value for f prime, then that means it's not differentiable, and we said that functions are not differentiable when there's a discontinuity or a cusp or a corner. So that's how they're all connected, okay? And then if it's a continuous function, Ellen, when we look at it, we can't ignore the stuff on the ends. Those are y values too. So our function goes beyond our relative domain, okay? And in this case, when x equals 4, it's off the screen, but over here, when x equals 4, right, it's off the screen, y equals the 1.6, and it's off the screen. Does that make sense? And so the question that they're asking us is, hey, what's the minimum value from x equals negative 1/2 or positive 1/2 to positive 4? And what's the maximum value? And that's what we kind of calculated. And there's some other behavior in between, all right? Okay, good. Any other questions? Do you guys feel a lot better today than you did yesterday?
Yes.
Okay, good. That's kind of how it's going to go sometimes. Oh, Saved by the Bell.